Hopefully you can all see that okay. Yeah, so thank you for the opportunity to speak with you today. As Jay mentioned, it's great to be back in Northeast Ohio, albeit virtually, but spent a number of years at the Rockwell Automation Twinsburg plant, working around the Cleveland area, and was the plant manager in Twinsburg for a couple of years. Currently at AWS now, I manage our manufacturing solutions portfolio, and so what I'm looking forward to speaking with you today about is how we're helping manufacturers build resiliency and improve business continuity in manufacturing. So I'd like to start with these survey results from McKinsey, because I think it highlights that while we all have experienced change over the last several months, going forward, the fundamentals of how work gets done are changing. And there are very discrete ways that the resiliency of the traditional workplace has been challenged. So our meeting cadence, our operating rhythms, how leaders lead day to day, the technology systems that we're using, and core processes, all of this are really being reevaluated here for the new normal. And so today, what I'm planning to share with you are a few examples of the changes that we at AWS are seeing manufacturers make to help improve resiliency and build business continuity. And so as we go through the handful of slides here, we'll break it down to three challenges. First is improving design and collaboration, and then how we're helping better manage supply chain variation, and finally supporting modernizing production operations. So first, with product and production design, we've seen manufacturers realize that it can be really difficult to run modern processes on traditional infrastructure. The corporate data center is oftentimes simply not fit for current resiliency requirements, as it is inflexible, it represents a high fixed cost, and it's oftentimes poorly utilized or capacity managed. Plus, the corporate data center was typically built under the assumption that the key workloads it supported, such as product lifecycle management or PLM, CAD, simulation workloads, ERP systems, etc., would be run and executed on premises, and at least would have the majority of the users sitting in the office. And as we've all experienced over the last couple months, that assumption hasn't necessarily held true. And I think as we talk with manufacturers, one of the lessons learned is as we prepare for the future and prepare for future resiliency, regardless of what the return to work policy might be, or how companies are going to handle continue to work remote, it's just been recognized that there needs to be the capability to still achieve the same levels of performance across some of these critical systems if employees are working remotely, full-time, part of the time, or whatever the case might be. And so these challenges have really driven an increase in cloud migrations for these critical workloads. And manufacturers have realized the benefits that a modern cloud-based infrastructure can provide, especially from a resilience perspective. So one, the infrastructure is flexible and scalable, so there isn't a need to over-provision, and capacity management of the hardware essentially becomes automated. Then systems are also available anytime, anywhere. And this empowers remote employees to work efficiently, whether they're in the office or working remote, and enables greater collaboration across teams, especially design teams. In addition, it's cost effective. The cloud cost model is one where you pay for what you need. Manufacturers are able to then transition the fixed cost of the corporate data center to a variable cost and adjust according to demand. So one example that I wanted to walk through, and it comes from one of our manufacturers or clients that we work with in Korea, Samsung Engineering. And they were challenged with how to connect to their 2D and 3D design software as they would do customer deployments. So a deployment oftentimes required employees to travel or at least be present in the headquarters office and in order to work with the required systems. And in some cases, they also needed to establish a local server infrastructure. However, this just was becoming increasingly challenging during the pandemic or during the last couple months. And obviously, Samsung wanted to continue to stay committed to the projects that it had rolling out with its customers. So they needed a new solution for how do we handle these 2D and 3D software systems and continue to deliver on the deployments that we have planned. So they were able to work with Amazon, and we did an implementation of Amazon AppStream, which enabled them to run the software on a virtual machine and basically support users in accessing that system from a variety of devices virtually anywhere. And so at the end of it, the implementation resulted in about a 20% cost savings compared to the on-prem infrastructure. And it cut the deployment time from 2 months down to just 7 days. Plus, if employees could not come to the headquarters office, if they were still on travel restrictions, for example, it really wasn't a problem any longer. Samsung could still support their customers with what they needed to do to get the deployment completed. So a second challenge that we've seen manufacturers face is how to build resiliency in supply chain processes, and specifically how to manage increasing demand and supply variation. So there's a handful of surveys that we've been able to reference. And this one in particular, I think, just highlights how, one, nearly all manufacturers have said, hey, there's a risk. We definitely have a risk around supply chain disruption. But then two, as we start to drill into that risk, it becomes more clear where some of the specific challenges are where we can help manufacturers address. And that specifically usually comes around how do we better manage demand fluctuations and supply variations. And I think this is going to continue to be an issue as we head into 2021. Obviously, we've seen a lot of variation in demand hitting manufacturing plants, almost regardless of what industry or what you're manufacturing. It's impacted demand one way or the other. Sometimes we've seen a spike in demand for toilet paper, and other times we've seen a fall in demand for maybe industries related to travel, for example, right? But in addition to that, I think as we come out of the pandemic and start entering into recovery, we're also going to start to need to better address supply variation, as some of our suppliers are also bringing their facilities, their capacities back online, or at least back to pre-pandemic levels. And so the question really becomes, how can we help manufacturers resolve some of these challenges? And usually we start from a point of just trying to understand, first, what are the systems today and how are they performing? And just maybe as an indicator too of the importance here or the interest in these types of use cases, we found that a number of manufacturers have basically turned off APO or turned off their traditional demand planning methodology because it simply is incapable of sending the right signals given the variation that we've experienced in the past 6 to 9 months. So again, a fundamental shift in how work gets done and a fundamental shift in how we need to be thinking about resiliency in the processes for the future. So what we've seen manufacturers asking for are technology solutions that can help them in a number of ways. And I've broken that into 4 main categories here. First is, how can we use technology to improve real-time visibility into what's happening throughout the supply chain? Get a better idea of what our suppliers are doing and where our inventory positions are throughout the entire supply chain. Second is to help scale predictive analytics that are actionable and that can enable us to move away from just looking at reactive metrics or reactive dashboards. I think what's key here too, just leveraging some of the experiences or examples we've seen around machine learning implementations, is that it's not only important to develop machine learning capability and get to the point of having an insight, but that predictive insight is only good if you can take action on it. So what's also key is helping support manufacturers around how do we land that insight into an existing workflow, or how do we automate the associated action to simplify execution? And that's ultimately how we start to improve the return on investment or the ROI of these predictive or analytics type solutions. And then third is, how do we leverage existing systems as much as possible? And this really allows us to mitigate risk and accelerate time to value. For example, in that earlier discussion around design systems, there are a number of opportunities that we've seen where manufacturers are looking to, for example, migrate their PLM systems, just lift and shift those PLM systems to the cloud. There are also examples where we just need to enable the current systems better using something like an AppStream that allows you to set up a virtual environment. And then fourth is, how do we develop easier ways to implement artificial intelligence or machine learning technology in a way that really augments current processes and drives improvement. So, how do we basically lower the barrier to entry there in terms of being able to implement AI and ML into the production floor or into supply chain processes? And so that's really the example that I'd like to double click on and offer you how we at Amazon.com have been able to apply machine learning and AI to improve the demand planning process, and how we've simplified that over time in terms of how easily it can be adopted into the process. So at one level, it can be easy to think of Amazon as just the public-facing e-commerce store. But in truth, there's a massive operation behind that website that enables us to deliver increasing value to customers, from our supply chain and logistic capabilities to the complex and highly automated operations that happen within the fulfillment centers. And if we go back in time, Amazon would use traditional statistical methods to develop a forecast at a product family level and take into account linear or seasonal demand patterns, all in an effort to achieve a forecast that was reasonably accurate. And I think this is common of what I've seen in most manufacturers as well, is still implementing good statistical modeling, but oftentimes somewhat limited both in the data that can be ingested and processed, or the models that can be used, or the variation that can be accounted for in those models. And then at Amazon, as the complexity of the product portfolio increased, and as Amazon considered how the demand planning process could be improved to enable better customer experiences like Amazon Prime or Prime Day, for example, we realized that traditional statistical method was just going to be insufficient for what we needed. And so starting in 2007, Amazon implemented machine learning into its demand planning processes. And with increasing amounts of data, have been able to implement deep learning since about 2015. And the result is that Amazon successfully plans on about a 16-day cycle. By comparison, many other retailers are around a 30 to 60-day demand planning cycle. And we do this across a global footprint of fulfillment centers and also a massive SKU portfolio. Now, while we've had success at Amazon doing that in retail, we've recently actually been able to start working with a number of manufacturers on implementing this same machine learning forecasting capability into their demand planning processes. These projects have come directly as an improvement action for the variation that we've experienced in the demand plan over the last few months. And we're typically able to leverage existing data sets, and given the capabilities of machine learning, can also add additional data sets that may not be considered today or may not be possible to involve in the forecasting process today. We then run these inputs through the machine learning forecasting algorithm and output the forecast with higher accuracy to the manufacturer's existing demand planning system. So again, we can leverage the existing ERP system or demand planning process that's in place. And we've seen positive results with POCs in as little as 3 weeks, and are currently engaged with scaling the forecasting algorithms across a wider portfolio of product families, as well as more complex product mix scenarios to start to drive additional results and more value as we prove this out in manufacturing specifically. Now, finally, how do we continue to build resiliency in production operations? So at AWS, we generally break down our smart factory solutions into 3 categories. First, we talk about asset performance management. And this is where we see manufacturers focusing on OEE improvements or overall equipment effectiveness, implementing data-driven maintenance strategies that span preventive, condition-based, and predictive maintenance, as well as looking at energy consumption or improving energy management of assets on the shop floor. The second category that we look at is quality management. And this is where we see manufacturers focusing on computer vision for defect detection or applying machine learning for predictive quality control. And then the third category is worker health and productivity. And here we see manufacturers focusing on developing the connected worker, digitizing the shop floor, and increasingly, especially over the last couple of months, applying technology to ensure employees are staying healthy, especially as they interact, obviously, with other employees on the shop floor or around the office. And so what we've seen over the last several months is that manufacturers have been accelerating smart factory or Industry 4.0 implementations. as a way to improve resiliency and business continuity, enabling remote support of the production floor, improving capacity utilization, and the speed at which we can scale, either up or down, that capacity model are key in the current environment. Plus, as always, we have an eye towards driving cost productivity and improving our customers' position on moving fixed costs to variable costs, improving productivity, quality, and delivery performance. And so I have 3 brief case studies that I'd like to talk through around how we've been implementing some of these smart factory solutions with manufacturers over the past 6-9 months or within the past year. First, our work with Volkswagen started actually before the pandemic hit, but I still wanted to include this case study as an example, I think a good example of where there's a long-term vision around Smart Factory Industry 4.0, and here to implement modernized manufacturing capability and enable cloud-based solutions. And at Volkswagen, the overall goal here is to improve productivity by 30% across all of their brands and their production facilities. And so as you can see by some of the detail on the slide, some of the early success has been around scaling production floor visibility, namely what's referred to as the digital shop floor management solution. Plus, the teams have been working on implementing microservices and blueprints for capabilities such as machine connectivity and data lake formation. These microservices and blueprints then accelerate the deployment of solutions across that spectrum of brands and production facilities that are in scope with Volkswagen. Now, as a second example, we've also had manufacturers approach us about just how to get started on smart factory implementations and then accelerate scale. And usually when we say, let's get started, we will work with the manufacturers around, what is the priority use case or what would give us the biggest bang for the buck, essentially, as driving some initial value. And in this case, this is working with a $3 billion brand of lifting equipment. And they wanted to start with using cloud-based solutions to detect paint quality defects that were resulting in increased warranty claims. In just a couple of months, they were able to deploy a repeatable paint monitoring solution that provided near real-time insights and scale that solution then to a second plant, again, just in a couple months. And as they scale, they're able to leverage AWS solutions to move faster, addressing multiple disparate communication protocols, establishing a common asset hierarchy, and setting an architectural foundation that really lays the groundwork then for the future innovation and smart factory use cases. So they're now on their way to executing a plan that connects all 7 manufacturing facilities with the same capability. And as a result, despite the challenges of the pandemic and some of the variation over the last several months, this manufacturer has accelerated their smart factory strategy and the resulting impacts that these technologies have on their customers. And then here's a final example. Let me see if I can get the video to play for you. I wanted to highlight what Amazon has deployed in our fulfillment centers around ensuring employee health and staying healthy and complying with social distancing guidelines. So as you can see in this example video, this is an application that presents employees with clear visual cues of the distance they are maintaining with others around them. And this solution is fairly simple and inexpensive to set up. It leverages an IP depth camera. In this case, it's an Intel RealSense camera. It runs on a laptop at the edge with a machine learning algorithm being used to detect social distancing. I'm just trying to replay it again here. And then obviously there's a TV monitor above that laptop to provide that visual cue. And in fact, the code for this solution has been made available open source on GitHub. And we've helped manufacturers download, test, and implement this code for use in their facilities. So it's a low-cost solution that takes advantage of the cloud to quickly meet a new requirement here around social distancing, and then be able to scale that in a cost-effective way across multiple facilities. And then finally, I'd like to end on, I guess, a point of optimism. It's been a challenging year. In many ways, it's hard to believe that we're already in November and Thanksgiving is just a couple weeks away here. But as Jeff Bezos says, with every one new thing, there come 2 new questions and 2 new opportunities. And we're really seeing manufacturers leverage the experience earned and the lessons learned over these past several months to consider the new opportunities that have been presented and the new opportunities that the cloud can make possible now in terms of making operations more resilient, flexible, and capable. And all of that in an effort to better serve and delight their customers. And so, we're definitely here and interested in partnering with manufacturers around how we can help on this resilience journey. And I want to thank you for the opportunity to review some of our work in manufacturing or review some of our work with these manufacturers with you today as part of the conference. If you have any questions, we'd be happy to follow up with you after the sessions today. And again, just want to say thank you for your time and hope you enjoy the conference the rest of the afternoon.